Okay, so I posted the first test. It's on sections 2.1, 2.2, 2.3, and that's it. I have set the due date to be the 24th at midnight. And we're going to put new homework assignments on pause for a little bit until the homework, till the exam and the other quiz are turned in. Okay, so you also have a quiz on Canvas. And so I took advantage of the internet today and did a round of homework extensions, and I looked at some emails. What else? So I just want to remind you that overall, my goal is for us to get practice. If you're falling behind in the class, just let me know and I'll give you an extension on any assignment, including quizzes and exams. Also, if you want to do a past homework assignment, let me know. I can open it up. And if you need more tries, just let me know about that too. I can add like 10 or 20 tries. You can get all the practice you can get. All right, we want to finish 2.7, and that's all for today. Before we start, I just want to say a few more things about the test. If I can remember right, there's 15 questions. It's estimated to take an hour and a half to 2 hours, and it should be similar to your homework. I'm pretty sure that I put 10 questions on the quiz. I'm going to grade it, and I like to give partial credit. So if you put most of the answer, I would give you most of the points. All right. The derivative of a function f of x at point x equals a. Oh, also on the side, I guess there's 12 questions on the quiz. Yep. Okay. 10 or 12 questions on the quiz. 12 this time. Okay, the derivative. Okay, it's written f prime of x. So f prime of x. Okay, and it describes the slope of the tangent line to f of x at x equals a. All right. Okay, derivative is f prime of x, and it's the slope of the tangent line to f of x at x equals a. Good. Let's do this and that. So we talked about this last time. There's two ways you can do the slope. All right, either the slope of the tangent line we'll write as f prime of a, and it's the limit as h goes to 0 f of a plus h minus f of a, and everything's over h. Okay, the other way is to get your slope. I put f prime of a equal to the limit as x goes to a of f of x minus f of a divided by x minus a. Okay. So we have a cool title and then kind of like an intro to this next, or I guess last topic of the section. Okay, so let's do colors. Okay, so we have velocity is a rate of change, and in the next part. Okay. I'm gonna say it like this. We call S of t a. Okay, so this is a function, S of t. We call S of t a position function. So your function is S, your input is t. And h will represent elapsed time. Okay, the grumpy cat, he wants to go outside. I'll be right back. Okay, that was my cat. S of t is our position function. H is elapsed time. Then average velocity is going to be change in position over change in time. Cool. Okay, I'm just going to jump to the part where I talk about instantaneous velocity. Oh, let's see. No, I'm gonna, okay. I was gonna skip this part of the notes, but we'll talk through it. So I have that change in position from, let's see, x equals a to some other x value, we'll call x naught, being a plus h. Okay, is the difference between, so change in position, difference between your y values. But our function is called s, so we put in s of a and s of a plus h. So our slope has s of a plus h minus s of a over a plus h minus a. So average velocity I think has a little more to it. We're working towards that. Okay, so we use s of a plus h minus s of a over, well, a plus h minus a. Okay, so you have a positive a and a negative a, which leaves h in the denominator. And then we take a limit as h goes to 0, and that gives us instantaneous velocity. Limit as h goes to 0 of all of this right here. S of a plus h is s of a. Okay, so I just put that would be s prime of a. All right, so kind of a summary of what we just talked about. S of t is a position function, and then we're going to have a S prime of t, and we call it the velocity function. Okay, and also this function, s prime of t, for velocity, we call it v of t. While we're here, we're just going to write this down. We'll get to it soon. But if you take the derivative again, which is coming up, I don't know exactly which chapter, but we'll get there. But soon-ish, we'll have s double prime of t, and that will be our acceleration function. And for acceleration, we call s double prime a. So a of t is the acceleration function, which will be s double prime of t. And that's coming later. Let's go back to this. I think I've got just one example, and that's about it. So we'll do one today. Maybe next time we'll do another example. But for now, we've just got an object's position is given by s of t. S of t is a function equal to negative 16t squared plus 10t plus 400. Okay, and also these values, these outputs are some number, and that's measured in feet. So we're just going to. Okay, we want to find the velocity at t equals 2 seconds. Okay, t for time in seconds. S of t is height in feet, or I guess position. An object's position. Usually the object is something that's thrown into the air or dropped off of a cliff, but it could be something going just, I guess this would be, I think, a negative parabola. So I think this would be something going kind of up and over. That's too much. Let's just focus. We'll stay on the problem. I was thinking about looking at the graph, but we don't need to see the graph. We want s prime of t. Okay, what I did was I did the limit as h goes to 0. S of a plus h, subtract s of a and divide by h. Put your function in there. limit as h goes to 0. Actually, the function will be in there 2 times. First time the input is a plus h, which means we need a lot of room. Okay, we can make it work. We'll put this in, and then we'll subtract this. Like that. So we'll put in a plus h minus, putting in just a. Okay. I think it can make it fit. So negative 16 times 2 plus h. Nope. We need space. Okay, let's do this. And again, this is the last example, so once we get through the problem, we can say goodbye. All right. Okay, that's a little better. Last thing is this glare. Okay, good enough. So first, put in a plus h. By the way, t equals 2. So it's actually 2 plus h. Let's see if I can get this a little better. Okay. Nope. Okay, cool. All right. It's negative 16 times 2 plus h squared. Add 10 times 2 plus h. And add 400. Okay, subtract. Putting in h, so just a 6, oh, I'm sorry, putting in 2 for a. So I've got negative 16 times 2 squared. Add 10 times 2. Okay, add 400. So I've got everything. I just need to expand, combine like terms, and then we'll see if we can get the limit. Okay, so I'll write down what I got. I have a negative 64 minus 64h minus 16h squared. That's just this part here, and then add 20 and add 10h. add 400, and then subtract this number. Which is going to be a positive, let's see, 16 times 2 squared. Then minus 20 minus 400. And things canceled. So I've got a positive 400 and a negative 400. Positive 20, negative 20. And let's see, there's negative 64, a positive, oh wait, we got the 20 and the 20, that and that. Oh, 16 times 2 squared. That's adds up to 0. So what's left is negative 64h. Minus 16h squared. And then plus 10h. Over h. Okay, from the numerator, you factor out one of those h's, or just factor out h. H times negative 64 minus 16h plus 10. Wait, those h's go together then. That's fine. I just put negative 64 minus 16h and 10 over h. Those reduce. Oops. Got this with that minus my 16h, and then you let h go to 0. And you do the limit. So this goes to 0, so that whole part is a 0, and negative 54 will be your answer. Let's see. It's a velocity in feet per second squared. Okay, so that's all I have for today. I feel like I'd want to do maybe one more problem. Really, all we're doing is practicing finding the slope of a tangent line. Let me make sure I said that right, which is practicing finding the derivative. But I want to practice also using all of the vocabulary with velocity and position and T for time. So let's try one more next time. And then we'll get into the last part of this chapter. So we'll do 2.8, and that will be the end of chapter 2. All right, thank you, everybody.